So let's look at the statewide air quality considering ozone. So only for ozone, 1998 to 2008. Up until 2008, the standard was 0.085. From 1997 to 2008, the standard was, ozone standard was 0.08 ppm over 8 hours. The standard was made more stringent. What we see is for the state of North Carolina, the ozone has continued to decrease, largely the state as a whole. But in certain pockets, it continues to be a nagging problem. And those pockets are, number one, the Charlotte region, number two, the Triangle region, and number three, the Triad region. But nevertheless, the good news is we have been able to manage and bring the ozone concentration down over the last 10 years, quite a bit. And this shows us during which months do we have the most problem. And indeed, June, July, and August, the maximum number of days is when you have the ozone problem. So June, July, and August. That is because we have high temperature and more sunlight. Now going from west to east, from the mountains in the state of North Carolina all the way to the coast, which is really Rocky Mountain. It's not at the coast, but close enough. And what do we see? We have an ozone problem in Charlotte. We have an ozone problem in the Triad, Greensboro, and we have an ozone problem in Raleigh-Durham, where the red line is the standard. If you are above the red line, the concentration is above the red line, you have an ozone problem. If you are below the red line, you are in good shape. And indeed, this is where, which is Charlotte. But that too has some good news. This is ozone concentration in parts per million in Mecklenburg County in North Carolina from 1994 to 1996, all the way to 2007, 2009, there has been an improvement. We are not there yet. There meaning 0.075, which will be somewhere here. We are still above the standard, but there has been a steady decline in our ability to manage and control ozone in the region. Same is true for Raleigh-Durham. The ozone has declined over the last 10 years. But it's still not below the 0.075, the new standard. And this data was collected by the state of North Carolina. They have monitoring stations around the state. So you simply go ask for it, and they provide it to you, and you can do the analysis associated with it. Now I'm going to spend some time in a research realm and show you some exciting research. Now, as Professor Weir pointed out, ozone is not just a local issue. It is also a regional issue. And I'm going to show you the regionality of this issue. So, North Carolina, Candor, North Carolina. Okay? Candor is somewhere halfway between Raleigh and Charlotte here. So Candor is, okay? And the second place, keep in mind, is Auburn, North Carolina, which is slightly southeast of Raleigh, these two locations. My students did an experiment there. Two different experiments altogether, completely different. And the idea of the experiment was to figure out how much ozone advects. The word advects means how much ozone is brought into the region. If that ozone is brought into the region, you can do paltry little about it because that's what comes in. You have no control over it. So you got to build from there. If you add that to what you're already making in the region, then you really have a serious problem. So the idea was to figure out how much ozone is being brought into the state of North Carolina. That's what we were trying to figure out. And the first way we did it was in Candor, North Carolina, and this is results from Candor, North Carolina. We made measurements of the precursors, NOI minus NOx. This is how, when NOx, which is oxides of nitrogen, gets transformed into nitric acid and the like. That is what this difference means. And ozone concentration on the y-axis. So, on the x-axis, you have essentially oxides of nitrogen. On the y-axis, you have ozone. When you mathematically take NOx to 0, you extrapolate this line, you'll come to about 30 parts per billion. So 30 parts per billion is what is coming into the state of North Carolina. No control over it. That's the regional issue. And these measurements were made by a variety of other investigators around the whole Southeast. This is Candor, North Carolina, which is these dots right there. Giles County, Tennessee, in Alabama, Metro, Georgia, and model that we ran, modeling exercise that we did. They all fall along a similar curve. And when you extrapolate this curve, you come to about 30 parts per billion when there is no NOx in the region. That means you are not producing any ozone. That value is 30 parts per billion. The second issue is you can see that as you change NOx, ozone goes up and down. As you decrease the oxides of nitrogen, you decrease ozone. So the control strategy that is left with you is to be able to control oxides of nitrogen, the precursor oxide of nitrogen. And the third issue here is the slope of this curve. And the slope is height over this over this. That's what the slope is. Rise over run. And the slope of this curve is about 12. What does that mean? That means for every molecule of NOx, you're making 12 molecules of ozone. That means NOx is very proficient in making ozone. So from this one curve, you can determine a lot of information. But the most important one was the background ozone that is brought into the state of North Carolina.